Using the capacity management, planning, and forecasting capabilities of VMware vRealize Operations Manager, organizations can operate IT assets as efficiently and cost-effectively as possible. In this module, we will show you how administrators can use vRealize Operations Manager to assess capacity risk, reclaim resources, streamline capacity planning and forecasting, and balance workloads within and across clusters. Here are the things you should be able to do after completing this module. One of the basic requirements of an environment is that enough resources are available to perform in peak times. Even if the data center is healthy, it is important to review the near-term future. Does enough hardware exist to fulfill current and future demands? When should additional resources be added? The efficiency badge on the recommendations dashboard can help identify resource optimization strategies and opportunities. vRealize Operations Manager triggers efficiency alerts for opportunities to optimize resource use. For example, built-in alerts trigger when a virtual machine has large disk snapshots, or if a group population efficiency is degraded. Administrators can use these alerts as starting points for identifying issues with resource use. In addition to the efficiency information provided on the recommendations dashboard, administrators can use the capacity remaining, time remaining, and stress tabs to assess whether an object is experiencing resource capacity risk. Let us see how an administrator can use these badges. Anita, the Virtual Infrastructure Administrator, builds and manages the virtual infrastructure. Based on some recent trends and alerts, she suspects that resources may be an issue for Cluster Production 2. She wants to see the available capacity and how much space is left. She begins her investigation by going to the cluster on the Environment page. A quick look at the Summary tab shows that there are no immediate issues for the cluster, so she will dig a little deeper. Anita goes to the Analysis tab to assess the capacity of the cluster. Here, she can see from the Workload badge that the workload is at a critical level and highest by memory consumed. A quick look at the badge colors for capacity remaining, time remaining, and stress shows that capacity is at a critical level. Anita clicks the Capacity Remaining tab to learn more. The Capacity badge provides an early warning of upcoming provisioning needs. It represents the capability of the object, in this case the cluster, to accommodate new virtual machines. The score is the percentage of usable capacity that has not yet been consumed. Here, Anita can see that no usable capacity is available for disk, memory, and CPU. Right now, she is going to focus on memory capacity, since the Workload badge shows it is the most critical. Keep in mind, though, that the process to analyze any type of resource is basically the same. The What Will Fit section provides an estimate of the number of virtual machines that can fit into the capacity remaining for the object. In this example, capacity is over by 11 medium-sized virtual machines or 17 small virtual machines. Metrics used to calculate what will fit are based on profiles. Default profiles include average, small, medium, and large. You can also create custom profiles based on specific sizing requirements in your environment. Anita scrolls down to learn more. For each resource, the Capacity Breakdown panel provides total capacity configured for the resource, percentage of resource capacity used for buffers, amount of usable capacity that is consumed by the object, Percentage of usable capacity consumed during peak times. Percentage of usable capacity demanded during non-stress times. Stress accumulates when a workload exceeds the stress line. And percentage of usable capacity remaining for the resource. The vSphere configuration limit row shows the number of virtual machines that can be deployed on the selected object. This value is based on the current amount of unused resources and the average virtual machine profile. Anita can see that memory capacity for the cluster is at its limit. Next, she goes to the Time Remaining tab. The Time Remaining badge measures the time remaining before an object's resources reach their capacity based on a 1-year scale. When calculating time remaining, the number of days to procure new resources is included in the calculation. The number of days is referred to as the time provisioning buffer, and this buffer time is configurable. Since no capacity is remaining, the score is 0, and the line to 100% is running straight up. Anita next views the Stress tab. Stress is how often a resource workload spends above the default stress threshold value for workload, which is 70%. While workload is based on an instantaneous value, stress measures statistics over a longer period of time. A high stress score does not imply a current performance problem, but highlights the potential for future performance problems. Here, Anita can see that for the past 6 weeks, 191% of the cluster's workload has been above the threshold of 70%, with the stress trend increasing over the last 30 days. The Business Week Workload panel provides a quick overview of when the object has the highest potential to run under stress. Blocks in the orange to red color range indicate stress over the 70% threshold. In this case, Anita can see that the cluster is under chronic stress. And as she suspected, memory is the most stressed. When Anita scrolls down, she sees the Child Objects with Stress panel, which shows stress by resource and the child objects that are stressed. Anita can see here that one virtual machine is stressed by both CPU and memory. Details are shown in the chart below. Based on Anita's investigation, she now knows that the Production 2 cluster has reached capacity and will soon be causing health issues. At this point, she has 3 options: reclaim some resources from the virtual machines in the cluster, increase resources by buying more hardware, or rebalance the workloads on existing hardware. In the next 3 sections, we'll look at how vRealize Operations Manager can help with these 3 options. The Reclaimable Capacity tab on the Analysis tab identifies resources that can safely be reclaimed. Let us see how Anita uses this tab to see if there are any resources she can reclaim for the Production 2 cluster. The Reclaimable Capacity badge indicates over-provisioning in the environment. Anita can see from the score that 29% of resources for the cluster can be repurposed. The Breakdown panel shows how much of each resource can be reclaimed, and a percentage of the provisioned resource. When Anita scrolls down, she sees details of the child objects whose capacity can be reclaimed, and the reason the resources are available. Anita can see that there is a little memory that can be reclaimed, but it won't be enough to solve her capacity issue. Still, she wants to reclaim it, so she scrolls back up to the top of the tab. To reclaim the available resources, Anita clicks the Virtual Machine Reclaimable Capacity link. The link takes Anita to the Details tab for the cluster. Here, Anita can see a detailed list of reclaimable resources by virtual machine. To reclaim a resource, she simply selects a virtual machine and then chooses a command from the Action menu. One last thing that Anita wants to look at while she is looking for optimization opportunities is the density badge on the Analysis tab for the cluster. Monitoring density helps Anita achieve higher consolidation ratios and cost savings. The density badge compares the current density with the optimal density that has been determined by vRealize Operations Manager based on policy. The higher the density score, the better and closer it is to optimal. Density information includes the ratio of virtual machines to physical hosts, the ratio of virtual CPU to physical CPU, and the ratio of virtual memory to physical memory. In addition to the badge score, the Density tab shows the current consolidation ratio, how the ratio is trending, and how the trend can be improved without causing resource contention among the virtual machines. Anita can see that resource consolidations for the cluster is good, and there are no additional consolidation opportunities at this time. One of the common issues in capacity planning is the sudden and unpredictable change that can occur when new projects are onboarded or when new hardware comes online. Using projects, you can visualize how one or more changes might affect the environment with the intention of committing and ultimately implementing those changes in the future. Projects can be applied to individual objects, such as virtual machines, or container objects, such as hosts or clusters. This table shows the types of scenarios you can model. A single project can contain up to 5 scenarios. Let us see how Anita creates a project to model current and future memory demands for the cluster. To get started, Anita goes to the Projects tab for the Production 2 cluster object to view the current state. By default, the tab shows the most constrained resource for the selected object, which in this case is memory consumed. The blue line shows the resource trend. The green line shows current capacity. The difference between the lines indicates the resource shortfall over a period of time. Anita wants to determine how much memory is needed to address the current shortfall and satisfy demand into the future. She also has a requirement to add 5 new virtual machines to the cluster 1 week from now, so she needs to ensure that there is enough memory to satisfy that new demand as well. Anita clicks the Add icon to start a new project. After naming the project, Anita drags a host system to the scenario panel and supplies a start date and the host metrics. The graph shows that one host will be enough to supply memory based on the current use trend. But will it be enough for the additional 5 virtual machines? Anita drags the Add Virtual Machine scenario to the panel. This time, she clicks the Populate Metrics From button and chooses a virtual machine in her environment to populate the metrics. Then she increases the number to 5 virtual machines and sets the date to 1 week from now. When Anita saves the project, the graph shows that adding one host will not support the addition of the 5 new virtual machines. Anita modifies the Add Host scenario by adding one more host and applying the change. She can now see that this additional capacity will satisfy the demand of the new virtual machines, plus provide a little room to grow. Anita is ready to commit the project. Projects can exist in 2 states, planned or committed. A planned project is a test to see what happens if you made certain changes to your environment. Committed projects, on the other hand, are changes that are committed to happen and therefore impact the capacity visuals. Committed projects are taken into consideration when calculating badge scores or when doing capacity trending analysis. Anita commits the project and saves it. An important feature of projects is that you can save them and make them persistent. After Anita saves the project, it shows in the list here along with other projects that have been created for the object. Should Anita need to edit, change the status of, combine, or compare projects for an object, she can always retrieve the project. Here, Anita can see that the project is committed and that it affects the time remaining and capacity remaining badges. To see how the committed project affects those badges, Anita returns to the Analysis tab. A quick look at the badges on the tabs shows that the addition of the two hosts will resolve the capacity risk. On the Capacity Remaining tab, Anita can see that even with the 5 virtual machines accounted for in the project, the remaining capacity will support 16 more average-sized virtual machines or 11 medium to large virtual machines. Based on her analysis, Anita is confident that purchasing 2 new host servers will fulfill current and future demand. In many data centers, workloads are often placed suboptimally, resulting in inefficient use of clusters and chronic resource contentions. Resolving contention by balancing resources is a difficult, time-consuming, and non-strategic activity. VMware vSphere Distributed Resource Scheduler, or DRS, moves virtual machines within a cluster to ensure virtual machines are always running on a host with adequate resources to support it. However, once a cluster has been completely utilized, vSphere DRS cannot move the workloads to other underutilized clusters in the data center or custom data center. vRealize Operations Manager enhances vSphere DRS by providing a rebalance container feature that moves virtual machines between clusters, thus ensuring that the clusters are balanced in the environment. Let us see how an administrator can use this feature. Anita would like to see if it is possible to provide additional capacity to the Production 1 cluster by redistributing workload rather than purchasing new hardware. To do so, she goes to the Workload Distribution widget by displaying the Workload Utilization dashboard from the home page. Here, she can see how the workloads are spread across data centers, clusters, and hosts in the environment. The widget places the objects in 3 zones: underutilized, optimal, and overutilized. The data center has 2 clusters, Production 1 and Production 2. The clusters are quite different in terms of their amount of workload. Production 1 has a very high workload score of 83, while the other cluster has a low workload score of 20. It looks like Anita can move some virtual machines between these 2 clusters to alleviate stress and reduce risk. Anita goes to the Analysis Workload tab for the cluster and chooses Rebalance Container from the Action menu. vRealize Operations Manager shows a rebalance plan that proposes moving a couple of large virtual machines from the Production 1 cluster to the Production 2 cluster to rebalance the CPU demand. vRealize Operations Manager is also going to move a virtual machine from Production 2 back to Production 1 to reduce a potential imbalance on memory consumed. Anita reviews the plan and clicks Begin Action to begin the moves. She can track the progress of the rebalance action on the Recent Tasks section of the administration page. In a few minutes, Anita returns to the Workload Utilization dashboard and verifies that vRealize Operations Manager has properly rebalanced the 2 production clusters. She can see that they now have very similar workload levels. In addition, looking at the host systems below, she can see that workloads are better distributed across the clusters, so DRS has more available resources to leverage. Because of this, DRS has been able to move some virtual machines within the clusters, and the result is these hosts are more balanced across the entire data center.